Okay, here we're going to look at a proof of the quotient rule. So what I'm going to show is that if I have a function or the quotient of two functions, so if I have f divided by g of x, which is the same thing as f of x divided by g of x, if I differentiate that, I get the following. I get g of x times f prime of x minus f of x times g prime of x over g of x squared. This is what we need to show. So let's start with this guy on the left side. So let's say we have some, I'm going to just call it a new function. Let's say we have some function h of x, which is equal to f of x over g of x. Okay, let's take a look at what h prime of x is. Well, that is the limits as delta x goes to 0 of h at x plus delta x minus h at x over delta x. But this h of x plus delta x, remember h of x is equal to this. So this is going to be the limits as delta x goes to 0. Now, one of the things I didn't mention here is that f and g both have to be differentiable functions at whatever x value you're looking at. So this whole thing breaks down if either f and g aren't differentiable functions, or g of x is equal to 0, or g prime of x is equal to 0. So we do have some, hang on one second. Okay, so what I said here was that f prime of x and g prime of x must exist, and g of x can't be equal to 0. I might have said that g prime of x can't be equal to 0, but it can. So g prime can be equal to 0, but g itself can't be 0. Okay, so now that we've got those formalities down, what we're going to do in here is we're just going to replace it with this. So what I've got is, and this is kind of a mess here, it's f at x plus delta x over g at x plus delta x minus f of x over g of x, and that whole guy is divided by delta x. Okay, so let's keep going here. That's the limit as delta x goes to 0. Now this in here, we need a common denominator. So what I have is the following. It's f at x plus delta x. I already goofed that up there. Times g of x minus f of x times g of x plus delta x over delta x times g of x plus delta x. Actually, I don't even need that around there. Just put a little multiplication symbol in between. Times g of x, like that. So what I've done here is I got a common denominator on my top, and then I knew this would be the denominator here. So this right here, this guy right here, was the numerator, and now I'm multiplying it by 1 over the denominator, and that's how this guy showed up down here. Okay, so now what I'm going to do is I'm going to do another trick here. What I want is I eventually want this right here. I needed to have an f of x. Well, excuse me, I need to have a g of x and an f of x in it so I can factor it out. So what I'm going to do is I'm just going to do the same trick as I did with the products, and I'm going to write this so that I'm going to subtract f of x times, now here I'm just going to subtract it times g of x, okay, and I'm going to add f of x, g of x, and then we're going to subtract f of x times g of x plus delta x, like this. So really the only new thing is this guy right here and this guy right here. Okay, so not too bad so far. So that's the limit as delta x goes to 0 of. Now what I'm going to do is I'm going to factor out a g of x up top here. I'm going to be left with the following: f of x plus delta x minus f of x. And then over here, I'm actually going to factor out, I'm going to switch spots with these two guys right here. And I'm just going to factor out, well, I'll factor out a negative f of x. So what that's going to do is, I can think about it like it's just switching spots. Okay, but it's going to be g of x plus delta x minus g of x, because I factored out a negative f of x. So this guy became negative, this guy became positive, and I just switched the order of them. So no big deal there either. Whoops, I forgot to write down this guy here. And of course, that guy's important. So this is delta x times g of x plus delta x times just g of x. Of course, we need that same guy right here. So delta x times g of x plus delta x times just g of x. Okay. We're doing pretty good. We're almost there. So what I can do here is I'm going to rewrite this whole thing like this. I'm going to write it as 1 over g of x plus delta x times g of x times, okay, now I'm going to take each of these guys and split them up. So this is going to be, in fact, I'm even going to pull this g of x out front. So g of x times f of x plus delta x minus f of x all over delta x. We can put this guy over 1. Minus, okay, what do we got left? I've got I can factor out that f of x, so f of x over 1 times g of x plus delta x minus g of x over delta x, like that. So what I've done is I've taken this guy, brought it out. I've taken each of these guys and I've put them over this, which is fine. I haven't broken any algebra rules. So now what I can do is I can take the limit of each of these guys all separately. So I can take the limit of 1 over g of x plus delta x times g of x times the limits as delta x again goes to 0 of g of x over 1, which is just g of x, times the limits as delta x goes to 0 of f of x plus delta x minus f of x over delta x. Okay, then I'm going to subtract the limit as delta x goes to 0 of f of x, and then we're going to multiply that by the limit as delta x goes to 0 of g of x plus delta x minus g of x over that. Now, this guy over here, first, the limits as delta x goes to 0 of g of x is just g of x, because there's no thing in there for delta x. I mean, the delta x isn't the same as x, so those guys are different. Here, though, what we're going to use is we're going to say, and this is kind of as a side note, but the limit as delta x goes to 0 of g of x plus delta x, this is actually equal to g of x. And the reason for that is because g of x is differentiable. Okay, so we can get g prime at x. And since it's differentiable, it means it's continuous, which means that it's not like a situation where like the function all of a sudden goes from here and like jumps up like that. Because in that case, then this guy is not equal to this guy. But we know that g is differentiable at x, which means that this guy right here is equal to this. So we also know that g of x is not 0, and so this ugly mess gives us 1 over gx squared. Okay, so there's nothing wrong with that. And I should have put down here, right here, I still needed parentheses. Okay, if anyone caught that, good for you. Okay, so now we're going to multiply that by, well, this right here, the limit as delta x goes to 0 of g of x is just g of x. It's just the function. Okay, because we don't really care what's happening as delta x goes to 0, because g of x is just g of x. It's like if it was 2, it'd be just g of 2. Now here, this right here is f prime of x, and we know it exists, so we're good writing that down, minus this guy is f at x. Okay, this guy right here is g prime of x. And so, whoops, once I multiply in, I have this whole thing being equal to the low times d high minus high d low over low squared. And so again, this is f over g prime of x. So there's our proof.